Our next example is going to be a table that models college tuition. We see on the calculator that 1 credit hour is going to cost $168. 2 credit hours is going to cost $336. 3 credit hours costs $504. 4 credit hours cost $672. 5 credit hours cost $840, and so on. We want to look again for a change in input versus change in output ratio. So when we look at this table, we see that from 168 to 336, that is a delta Y, or change in output, of $168. We see from 336 to 504, that is a delta Y of 168. We see from 504 to 672, that's again a delta Y of 168. And to really see where these are coming from, we can again go to the calculator, and we can see that, for example, the 336, whoops, back up a little bit. If you make a mistake like that, you can always go back and type over it. 336 minus the 168 was in fact the 168, so that does verify the output change that we observed. We can also see that for our inputs that we're going to have delta x's equaling 1 this time, a delta x equaling 1 that time as well. So that tells us that our ratio, our delta y to delta x ratio, is a 168 to 1. In other words, a 168 for our ratio. So this tells us something about our rule. We can come down and erase this question mark and start figuring out what our rule is going to look like. If you pick some number n to be your input, that means your output is going to be, the rule for your output in part is going to be 168 times n. Again, we need to be able to figure out if it's going to be plus or minus some other value. In other words, do we have some sort of initial value that we need to figure in? To figure in that initial, what that initial value might be, we need to know what would the input of 0 have given you for an output. Well, backing up this table, since our delta y is 168, if we back up 168, 168, 168 each time, we see that a input of 0 would in fact have given us an output of 0. So this time then we see that the constant that we thought we were going to have to put here is actually going to be a 0. So our rule, in fact, was just 168x. 168 times x gave us this table, and moving back up the table, we can verify that the input of 0 did in fact give us the output of 0 as we predicted. And we could now use this rule, for example, to see what output would have been associated with an input of 15. In other words, 15 credit hours would have cost how much? Well, since the rule is 168 times n, I can go to the calculator and say 168 times 15. That tells us that we're predicting an output of $2,520 for that number of credit hours. And we can verify this by looking at the table that gave us this in the first place. And when we jump all the way down to 15, we do in fact see that $2,520 is the price for 15 credit hours. So in general, our rules for any input in, if we have a linear type situation occurring, in other words, a constant, consistent change in y, or delta y to delta x ratio, then our rule for any n value is going to be delta y over delta x, that ratio, times n, plus or minus whatever constant is associated with the 0 input.